Hey, so I don't think I'm going to be in on Wednesday. I've been sick the whole time, all day today, and I got about 100-degree fever. So there's a chance, but I doubt it. Anyways, I'm going to do the work for WebAssign N3 and N4 and leave you guys to take a look at the notes for the remainder of this packet. We still have to test on Friday. We really do not have a choice. So we'll start with N3, number one, nuclear fission reaction. We are given a loss of mass, and the first question is how much energy is produced. So we'll go E equals mc squared. My loss of mass is 1.067 E negative 29. C is 3E8 always. And go to calculator. And whoops. And pull up 9.603 E negative 13 joules. So we'll go 9.603. That. 9.603 E negative 13 joules. Checking and good. Now it would like us to say how much is in 50 grams of reactions. So 9.603 E negative 13 joules in one reaction times a total of 1.27 E23 reactions is going to yield a big number. Looks like 1.22 E11 joules. So E23 numbers all look good. Okay, so 1.22 E11. And so far so good. Convert to kilowatt hours. If you don't remember, you divide it by 3.6 million. So for part C, 1.22 E11 over 3.6 E6. And I haven't rounded on my calculator, so you might get a slightly different number than me. Kilowatt hours, 33877. And then our last question is, if we use 12,600 per year, how many years will this last us? So 33877 or 12,600. I would make sure that you know how to do one of these come the test on Friday. We'll check our answer. And victory. Okay, moving on to question 2. You have a piece of uranium undergoes, creates this much nuclear waste. How much energy is produced in the reaction? So we had 5793819. And after the reactions, we have this. You don't need to do this by hand. You can go ahead and use a calculator. That's what I'm doing because I'm tired and my head hurts. So I got a mass of 0.88177. So E equals mc squared. The amount of energy produced, 0.88177, times the speed of light squared, yields 7.94 E16 joules. So 7.94 E16 joules. And good stuff. Very last one. This much energy. how much mass did it come from? Be sure to use at least 3 decimal places. So E equals mc squared, doing the opposite of what you did in number 2. So you're going to divide it by 3e8 squared. So 4.2156. Oops, wrong number. I got 0.468 kilograms. 0.468. And that is the end of free. So I'll go on to number 4. Hopefully it didn't change my numbers. It did not. Cool. Okay. This one, you have 2 hydrogen 3s that become a helium-5 and a neutron. How much energy is lost? I'm sorry, how much mass is lost? So the change in mass would be 2 times the hydrogens. It's 5.02771 e negative 27 minus the combined mass of the helium and the neutron. So, okay. Again, you can expect something similar to this on your test on Friday. Almost to my answer. And 1.009 e negative 29 kilograms. 1.009. Oops. 1.009 e negative 29 kilograms. Based on your answer to part A, how much is produced in one reaction? E equals mc squared. 1.009 e negative 29. 3e8 squared. And that will be 9.081 e negative 13 joules. 9.0. And next question is, this many reactions are produced. So just like last time, 9.081 e negative 13 joules per reaction times 4. Oddly specific number, 442722 E23 reactions. 7. We have 4.52 E11 joules. 1.52. And convert to the kilowatt hour once again. 4.52 E11 over 3.6 E6. And 125,430 kilowatt hours. 125,430. And how many years? 12,600 per year. 9.95. So There you go. Next one, piece of matter, 23 kilograms is hit with a piece of antimatter. This is something we didn't really talk about. You won't need to do this in class or on the test, but for the sake of an argument, the mass total is 46 kilograms. Antimatter and matter, when they collide, completely annihilate each other and turn into pure energy. Something we used to talk about, but we don't anymore. So, but if you're curious, it's 4.14 E18 joules. All 46 kilograms, 23 of the matter and 23 of the antimatter, turn into pure energy. 4.14 E18 joules. And then our last one, loss of hydrogen into helium. So we'll start by figuring out what is the difference in the mass. That's a 4. I guess I'm going to do this one in my head now for reasons I don't know. So 0.0344 kilograms. And then the last step, multiply that by c squared to figure out the energy. (3e8) once again, the speed of light. And you end up with 3.096 E15 joules. And that's it. Again, test will still be Friday. We don't have a choice. So, because we have to have senior grades in, so we see what seniors are and are not taking the exam. Good luck.